Okay, so here's the answer key for pages 7 through 9. So again, hopefully try these on your own so that you know whether you're ready for the exam or not, and then use this as a way to check. So I know you can just cheat and watch me do it, but that doesn't, I don't know, something about missing it and figuring out what your error is. There's a lot of learning involved in that. All right. So better to do it that way than to just watch me. It's easy to watch me and be like, yeah, I get what she's doing. So, all right, let's look at Roman numerals. First of all, you have to write it out by place value because you have to build the 400, you have to build the 40, and you have to build the 7. So 400, you can't use CCCC. It's impossible to have 4 in a row. So you know you're going to have to do that add and subtract trick. So 500 minus 100 gives me 400. So remember, if it's after you add, so if I want to subtract, I need it before. So I'm going to go C, D. So I have D for 500, and I'm going to put the C in front so that I subtract the 100 to get the 400. All right, 40. Same idea. I can't have X, 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 X. 4 is not allowed. So I'm going to have to do 50 minus 10. So again, if the 50 had a 10 after it, I'd add and get 60. So I need to put it before. So I'm going to do XL because L is 50. If I put the X in front, I would subtract 10 and get 40. And then 7 is a 5 plus 1 plus 1. All right. And so since I want to add them, I want them after. So I'm going to do VII for that. Okay. The next one, I'm going to, again, it's a place value system, so you have to write out your place values, and it is positional. All right, it's, how can I say that? It's not really a place value system, but it is positional, so we do have to build each number. So 1,000 is just M. 300, it's fine to have 3 in a row, CCC. 70 is what? It is a 50 plus 10 plus 10, so X and X. So 50 is what? An L, and then XX. And then 9 is a 10 minus 1. So again, if I put it after, I would add and get 11. So I need to put it in front. Now, technically, there is another answer for this. The 1,000 is not negotiable. The 300 is not negotiable. The 70, if you wanted to, you could do what? 100 and then subtract 10 3 times. You usually don't see that, but technically it's legal. So you could have you want it in front because you're going to subtract XXX and then a C and then your IX. So again, that's possible, but I would say this is more common. Okay. All right. The next one, again, sometimes it's hard to know how many place values these are. So I see this is CCXLVI. So I have CC. So 2 C's is what? 200. So then I know this is like a 3-digit number. So then sometimes I go to the end actually, and I see this VI. And so then I'm like, okay, that's 6. So then I know the XL in the middle goes together. So the CC at the start gives me 2. The VI at the end gives me the 6. And so that XL is in the middle. Well, X is what? 10. And L is worth 50, and if it was after, I would add, and it's in front, so that means I'm going to subtract, so 246. All right, the next one, I have a D and an L. So D is what? 500, okay? So I'm in I have 500. And then the LX is, L is a 50, and the X is after it, so that means you add, so 10. So that's 50 and 10 is 60. And then at the end, I have 3. And again, sometimes I might start with the 500, the 3, and then look at the LX in the middle to get 563. All right, from number 3, it says, write 4,654 in Babylonian numbers. All right, so we're converting into Babylonian. They have a base 60. So I'm going to make a chart. Ones are 60 ones are 60 to the 0 power, which is singles ones. 60 to the first are your longs, those are worth 60. Their flats are 60 squared, which is 3,600. And I don't think I need bigger than that because a cube is going to be 60 to the 3rd power. That's way bigger than 4,654. So I'm just going to stop. All right, so it looks like I can divide 3,600 one time into 464. So I know I'm going to have 1 flat. So I'm going to subtract that, and I get 1,054 left. So now I'm going to try to package as many longs as I can. So 1,054 divided by 60. 60 doesn't go into 1, 60 doesn't go into 10, 60 goes into 105 once. I'm going to subtract 60, which is 45, bring down the 4, 454. Looks like 7 is going to work, 42. And then what is that? 34 left over. So I know I can do 17 longs. And then I have 34 left over. Those are my singles. Now, again, they don't have 1, and they don't have 17, and they don't have 34. So now I have to draw the picture. So I've divided and subtracted to get it into these packages, but now I have to draw them. So one flat would be a tack-looking thing. Okay. Again, the book or the online system makes them look kind of more like a V going up and down. They don't draw the tail on it. So it's kind of, they just draw the top part of it. And then 17 would be like the sideways arrow thing or the less than symbol. And then we would have what? 7 tacks with that. So 17 would be one of the sideways guys, and then that. And again, on my math lab, it might be a sideways guy with, again, 7 V's, because again, on their text, they don't draw the bottom. Probably just easier technology-wise. All right. And then 34 is 3 of the sideways less than guys, or the arrows, whatever you want to call them, and then 4 tacks, however you draw that. Again, on my math lab, they would do 3 of the sideways guys, and then their tacks would just be like up normal V's. Okay, so either one is fine for me. All right, so the next one, we have 10,489. Again, we're going to divide a lot and subtract. So I have my chart up above of 60 cubed, 60 squared, 60 to the first, 60 to the 0. Again, 60 cubed is going to be huge, so I know I don't need it. I'm only going to need 2 of my flats here. So 10,489, and I know that I can build, I'm just going to draw a flat. I'm going to have 2 flats, which is going to use up, what, 7,200. Subtract, and I get 3,289 left. All right, now I'm going to divide 60 into that to see how many longs I can make, because their longs have 60. 60 does not go into 3, 60 does not go into 36. 60 goes into 368 5 times, so I'm going to put a 5 above the little 8 there, just doing long division here. 300, I get 68 left, and then I'm going to bring down, oh, did I write? Oh, I wrote that wrong, sorry. That's a 2, 3,289. All right, so 60 still goes in there 5, but when I subtract 300, I get 289. All right, and then 60 goes into 289 4 times, would be 24 with a 0, 240. So when I subtract, there's what, 49 left over. So I have 2 flats. When I divide for the longs, I got 54 longs, and then I got what, 49 left over, so 49 singles. Again, you have to draw the symbols. So for the 2 flats, you're going to draw 2 tacks. For the 54, you're going to draw 3 of the sideways arrow guys or little triangle guys or whatever, less than guys. So 5 of those, and then 4 tacks. And then for 49, you're going to draw 4 again of the sideways less than or arrowy guys, and then 9 tacks. Okay, and that'd be there. Okay, 5, it says draw 2 tacks, okay, a space, 2 triangle bird shapes, so those are kind of like our arrowy guys or sideways less than guys, with 4 tacks. So that's in my middle place value, and then space, and then 3 tacks. All right, so I basically have a 3-digit number to them. I have 2 tacks in the first far left space, and then 2 of the less than or birdie triangle shapes with 4 tacks, and then a space, and then 3 tacks. Now, I want to convert it to us. Well, you can't, it's not easy. You can't just write 2, 24, and 3, because those are what the values are to them, but their value, they have a different place value system than us. The number in the place is the same, but the value of that place, they don't have tens and hundreds and thousands. They have 60s and 3600s and things like that. And remember, up here on 3 and 4, we divided and subtracted a lot to convert. So to unconvert, we have to do the opposite math. So we must have to multiply and add. So I have 2, 24, and 3, but what are they worth? Well, the 2 are flats, and their flats are worth 3,600. The middle is their longs, which are worth 60. So I have 24 times 60. And their 3 are singles. And then what I need to do is multiply those and add those, okay? So this is what, 7,200, 24 times 60. I'm just going to grab a calculator for time-wise. Otherwise, you could just multiply by 6 and tack on a 0. So 1440, and then plus 3. So I'm just going to add those up, 7,200, 1440, and a 3. Add those up, I get a 3, 4, 6, 8. So I know the answer is 8,643. And that would be like if I dumped all the individual blocks out, how many individual pieces would it be to us in base 10? And again, even if we grouped them in base 10, it's going to be the same answer because we group things by thousands, hundreds, tens, and ones. So the base 10 is the only base where the dumped out version and the grouped version is the same. That's why we can view it as just dumping those out. All right, let's look at number 6. All right, so number 6 is the same thing. It says draw a picture, and then we're going to tell what number it would be to us. So we have 2 of the little bird triangle things. So 2 of those like sideways V things and 1 tack. So that's our first place value. Then we have 4 of the less than or triangle-y guys with 2 tacks. And then in the singles position, we have 1 of the triangle bird guys with 3 tacks, okay? All right, so to them, that would be what? 21 in the first far left place value. In the middle place value, they would have 42. And in the far right, they would have 13. But again, yeah, they have those in those places, but that's not the value of those places, right? They're not worth 100 and they're not worth 1,000. They're not worth 10. They're not, they're not worth that. So now you have to put the value with it. All right. So the 21 is their flats position, which is worth 3,600. Their middle position is their longs, which are worth 60. And singles are always worth 1 in any base. And again, you have to multiply and add because you're doing the opposite math. Okay. And again, it can't be easy. If it's too easy, you're doing it wrong. All right, so 21 times 3,600 is 75,600. 42 times that is what? 2,520. And then the last one is 13. So then if I add those up, 5, 6, 7, 8, I get 78133. And that's what it would be if we dumped all those individual packages out into a giant pile of like tiny blocks. Okay. All right, then I told you could skip what? 7, 8, 9, and 10. So we're going to go back to 11, 12, and 13 here. All right, so I think I'm going to, how much time do I have? Okay, I'll try. Convert to Mayan. So Mayan is base 20 that's modified. So your singles are worth 1. Your longs are 20 to the first power, so those are worth 20. And then instead of 20 squared, they have 20 times 18. So their flats are rectangles, and those are what? 360. And then they go back to 20. So 20 times 18 times 20 is kind of a rectangular prism. It's not really a cube. And that would be what? 7,200. Okay. And they go vertically. So their singles are at the very bottom, and they work their way up to 7,200. So to convert, again, you divide and subtract a lot because you're packaging. So I can make the big kind of flat thing one of those. So that would use a, oh, no, I can't. I only have 342. Sorry, I didn't mean to lie. I cannot do that. So I don't even have enough to make a flat. So I can make long. So I'm going to divide by 20. 20 goes into 34 once. I subtract 20, and I get 146, and 20 goes into that 17 times, so 140, and I get 6 left over. So I can really just make 17 of their longs and 6 of their singles. All right, so how do they draw that? Okay, well, on the bottom 6, they would do a line segment with 1 dot above it, because that would be like a hand with 1 finger. That adds up to 6. And then above that, 17 would be 5 line segments for 15, 5, 10, 15, and then 2 dots to get to 17. So bottom row is a line and a dot to make 6, and 15 would be 3 line segments with it 2 dots above it. And again, it's a vertical, okay? All right, I'm gonna have to make another video because I'm timed out at 15 minutes. So I will do 12 and 13 on the next video. So give me a moment. I gotta find my mouse. There we go.